So in this problem, we are given three forces shown. We have P1 equal to 12 kilonewtons, and P2 equal to 24 kilonewtons, and P3 equal to 16 kilonewtons. And we are tasked to solve the following. That is the resultant of the force system, the angle of the resultant from the x and y axis. And to solve this, we need to break down each force vectors into each individual components. Now for P1, it has no x and z component, only a y component that is equal to 12 kilonewtons. And for force P2, that lies on the xy plane, it has both x component and y component. And to solve for the x component, we utilize the cosine function to get the adjacent side. There's an angle of 30 degrees. Now to solve for P2, x component, we multiply P2 by cosine of 30 degrees. We get 20.78 kilonewton. And to solve for the y component, we utilize the sine function to get the opposite side. That is equal to 12 kilonewtons. And it has no z component because it lies on the xy plane. And for the force P3 that is acting on the xz plane, it has both x component and z component with an angle of 40 degrees. So to solve for the x component, we multiply it by the cosine function to get the adjacent side. So we have P3 equal to 16 times cosine of 40 degrees. That is equal to 12.26 kilonewton. And to solve for the vertical component, that is the z-axis, we multiply it by the sine function. So we have the z component equal to 10.28 kilonewton with no y component. Now to solve for the resultant, we first need to solve for the resultant along the x, y, and z axis. That is by summing up all forces acting along the x-axis to get the resultant at x. And to solve for the resultant component for y, we add up the y component of the forces, and to solve for the z component of the resultant, we add up all the forces component of z. So doing so, we get the resultant of x that is equal to 0 plus 20.78 and 12.26. We get 33.04 kilonewton. To solve for the resultant along the y-axis, we add up the forces, y component of the forces, that is 12 plus 0 is equal to 24 kilonewton. And to solve for the z component, we add up the z components of the forces. So 0 plus 0 plus 10.28 is equal to 10.28 kilonewton. Now we can solve for the resultant by taking the square root of the sum of the squares of the components Rx, Ry, and Rz. So we're just basically doing a Pythagorean theorem on the 3D plane. So you have square root of Rx squared plus Ry squared plus Rz squared. That is equal to 42.11 kilonewton. So the answer for the first problem, that is letter A. Now that we have our resultant, we can now solve for the angle of the resultant from the x and y axis. Now, if we have a resultant, let's say resultant vector r, and this is the coordinate axis, we call it x or y, we can solve for the angle between the resultant and the axis by utilizing the cosine function. That is equal to the adjacent side, that is the component acting along x or y, divided by the resultant vector, which is the hypotenuse. So cosine theta equals to the adjacent divided by the hypotenuse, r. So theta is equal to r cosine of rx divided by r, if you want to find for the angle between the x-axis. And solve for the angle of the resultant from the y-axis, we get the inverse cosine of r sub y divided by r. So doing so, we have the value for r sub x that is equal to 20.78 plus 12.26 divided by the resultant that is 42.11. We get 38.32 degrees. And to solve for the angle between the resultant and the y-axis, we have r cosine of ry, that is 12 plus 12, or 24, divided by the resultant, r. So we have 55.25 degrees. So to answer the problem, the angle of the resultant from the y-axis that is equal to 55.25 degrees, and the angle of the resultant from the x-axis that is equal to 38.32 degrees.